Okay guys, let's continue with question 4, 2024 A-Levels paper 2. Okay, part E, they say L, M and N are three separate samples. Each one contains a different halogenoalkane. One sample contains, okay, let me shift this a little bit. Okay, they say one sample contains chloro, another bromo, and another iodo. Ethanolic silver nitrate is added to each sample heated to a constant temperature. Stopwatch started. Time for precipitate to appear is recorded. The results are shown in table 4.1. So you see, the longer it takes for the precipitate to appear, right, the stronger the CX bond. Okay, so obviously, the shorter the time taken, the weaker the bond. So the first should be iodine because Ci bond is the weakest. Then followed by bromine. Then followed by chlorine. Okay, the color will be white, cream, and yellow. Okay, very easy, 2 marks there. Using relevant data from the data booklet. So relevant data, they are referring to the CX bond energy. Explain why the time taken for a precipitate to appear is longer. So you just need to quote all the bond energies. Ci bond is about 240, CBr is about 280, and CCl bond is about 340. Okay, so the weakest bond, right, will take the shortest time to break, and then the longest time to break is your CCl bond because it is the strongest. All right. Okay, let's look at this part F. I think this is the last part for question 4. Okay, the reactions of chloroethane, chlorobenzene, benzene ring with a chlorine, and ethanoyl chloride. Okay, with water are investigated. Chlorobenzene does not react with cold water. When cold water is added to ethanoyl chloride, rapid reaction occurs. Yeah, hydrolysis, yeah. Write equation. So this is pretty easy. Ethanoyl chloride plus H2O gives you CH3, ethanoic acid plus HCl. Okay, give 2 reasons why it does not react with cold water. So the first reason is because your partial double bond, okay, between carbon atom and the chlorine due to the delocalization of lone pair of electron from chlorine into the benzene ring. Okay, so this is reason number 1. Reason number 2, your water, right? Water is a nucleophile. So there is steric hindrance from benzene ring. Okay, benzene ring has this pi electron cloud which will actually hinder the attack of the nucleophile, which is water, so it does not react. Okay, part 3, the last part, explain the difference in reactivity. Okay, so ethanoyl chloride, right, this carbon is very delta positive because it's bonded to 2 very electronegative elements, O and Cl. Okay, but for chloroalkane is only bonded to 1 electronegative element, Cl. So it is this ethanoyl chloride is more electron deficient. Okay, carbon atom is more electron deficient. okay, which will allow it to be very susceptible to hydrolysis from cold water. Alright, so that's it for question